You can if you want. So you should have two assignments. You should have one from section 8.2 and you should have one from section 8.3. We are going to add in section 8.4 today, and then all three of those will be due tomorrow. If they are in your notebook, you could have left them in your notebook. If you've taken them out, well, then so be's it. All right. I will be checking those tomorrow in class while you are starting your review for your quiz, which is going to be on Monday. Okay. Today, we are looking at what are called special products. Okay. There are three special products that we're going to take a look at today that are, I guess, for a lack of a better word, really like a shortcut to some foiling processes that we already know or we've already started. What's up? This is 8.4. Yep. So this is the last part of essentially us putting polynomials together. The entire second half of this chapter is going to be us taking them apart. I know, because that's actually how you solve something that has an exponent power greater than 1. Because you have to factor. You have to pull its pieces back apart. So we'll get into that starting next week. All right. How many of you could answer this question? Let's say x plus 5 squared. Do you know what you would do? What would you do?
I would raise both of the things in it. Oh no, I'd multiply. So you do the 8 plus 5, and then no, you just make 2 of them next to each other. Or why did I say and 8? Multiply them.
Okay, so we're gonna have 2 x plus 5s, right? So take a second. No, it's not, because if you do first, outer, inner, last, it would not be the same thing. All right. So take a second. Tell me what the answer is to that. If you need to write it twice, and you think about your 4 parts, your first, your outer, your inner, and your last. What are you going to end up with? So remember, this is really x plus 5 and another x plus 5. Think you have it?
Yeah.
You got it.
I just have a question.
Yes?
So, like, for an example, say it was x plus 5 to the power of 3.
Uh-huh.
Spread it
3 times?
3 more times?
No, not 3 more, 3 total times.
Oh, 3 times.
Now be careful though. Look how you see, if you're writing that twice, notice up there, the squared is gone because I've replaced it with the fact that I'm writing that binomial twice. That's correct. Very good. Very good. All right. Good. So first, outer, inner, last. Good. Very good. This would not have a 2 in there because x times x is just x squared. Good. Very good. So as I put my first terms together, what do I get? My first terms. Good. So x times x is x squared. Next,
Outer.
which is?
Times 5, which is 5x.
Okay. So outers there would be 5x. Olivia, what's next?
Another 5x because the outer 5 is
Okay. Yeah. And then last is 25. 5 times 5 is 25. So my final answer here is actually, okay, very good. Okay. All right. What if it looked like this? What's your answer to that? The hope is that when you recognize one of the 3 scenarios we're going to talk about today, that in fact you don't have to FOIL at all. What's that? Good. Not that these produce the same answers, but you should see something falling in line. Very good. With both of these so far. Good. Yep. Very good. Yep. You and your 47 colors.
Sorry.
Yep. Yep. What's that? Yep. Yep. All right. Kyler, what are your 4 pieces that make this one up? Like in the first one, it was the x squared, 5x, 5x, and 25. What is this one? Plus 64. So your answer then, final answer is? Okay. One more. Yeah? All right.
We just do these all day. Like, they're easy. I found a weird pattern, but I don't know if it works.
Okay. What about if it's this?
I just did that one. I didn't have foil. I just erased it too. So I don't have enough hair on it.
Oh, you already have an answer
Yes,
without having to do anything.
Yep.
Where is it? Oh, you're so close. Your middle's not right. Good. Yeah, it's kind of my goal. Yep. Very good. Now, the hope here in a moment is that we understand kind of what's going on in this type of problem and how there are some kind of repeated thoughts in something that looks like this.
Okay, I don't know if this is right, but like, couldn't you just do like that x times x and you get x squared, and then the 3 plus the 3 and 6x, and then 3 times 3 and 7?
Very good.
That's what I did.
All right. Yeah. So as you look at these 2 pieces in this binomial right here, because they have identical factors, all right, we're saying, wait a minute, like, do I really need to do? No, you don't, right? What are my pieces here? It's this first item that's being squared. Anna, how did you end up with the middle part?
Like, I looked at the other equations.
Yeah.
They had the exact same thing, like 8 plus 8 is 16, and the 5 plus 5 is 10, so 3 plus 3 is about 16.
Okay, so here, because those outers and inners are going to produce the same pieces, it's like, wait a minute, I know that that's going to be 2 of those 3 x's, which turns into a 6. And how did you get this number on the end? 3 times 3, and you get a 9.
I mean, yeah.
Okay. So that is 2/3 of the idea we're going to take a look at today. All right. Now, your book uses a name that I don't use, and to be honest with you, I don't see used very often. So we'll talk about a different name. But what you just looked at is what's, according to your book, known as the square of a sum. Okay. The square of a sum. Square meaning 2 identical pieces there of a sum, obviously, of that addition that's taking place. We'll kind of list some things over here on the side, maybe more that would make sense for you to have in your notes. Okay. Secondly, we're going to look at the square of a difference. So instead of those 2 items being added together, we're going to look at them being subtracted from each other. And then lastly, we're going to look at what's called the product of a sum and a difference. So products mean multiplication of a sum and a difference. So instead of having 2 things that we're adding or 2 that are subtracting, we're going to have 1 of each. And so we'll see what that looks like too. This is probably one of the only homeworks from here till the end of the year where I would tell you no work would actually be what we're looking for here. If you recognize the pattern that you see in front of you, you really shouldn't have to FOIL it out in this case. Okay, so that's kind of where we're headed. We'll let these go for today. So those kind of fall in line with our objectives then. These square of sums and differences, that's the first two. And then the third one is this product of a sum and a difference. Okay. I found this graphic because I thought it made sense. You guys may look at me and tell me that I'm crazy. All right. Here's really what's going on, and you can look at any of the examples in your paper that we just had a second ago. We're looking at something that had two identical factors in it. Okay. For you in the first one, it was x plus 5. And then the second one, x plus 8. And then the last one, x plus 3. But whatever it was the same thing twice, right? And so what it produces, essentially, is a perfect square at the beginning. Do you know what a perfect square is? Anything that has an identical factor is a perfect square. What's your perfect square at the beginning of every one of your answers? X squared. What are the two identical factors that created it? X and x. That's how you get the x squared. You also had two values that were multiplied together that were not the same. In your first one, it was an x and a 5. In the second one, it was an x and a 3. Or excuse me, an x and a 8. And then the last one, an x and a 3. They produced two identical values that we doubled together. Are you with me there? What's the matter? I have something on my eyelash? Which one?
Your right eye.
My right eye?
It's in, no, it's like to the inner side.
What is it?
I don't know, it's white. It looks like I would or something.
Oh, maybe it was. And lastly, you have a perfect square at the end of each one of these. In your first one, it was 25. In your second one, it was 64. And in your last one, it was 9. Okay? This is what is known. So this is what you should put in your notes for today. This is what's known as a perfect square trinomial. Okay? Perfect square because the beginning and the end are both perfect squares. Trinomial because our answers result in having 3 pieces. All right? The first one that we're going to label here is exactly what you see in that graphic over there. When my sides could be thought of as a plus b squared, okay, that's really created by having two identical things, a plus b and a plus b being multiplied together. That will produce, when I FOIL, that picture that I see on the board over there. It will produce an a squared in the front. When I do the outers, I get a times b. When I do the inners, I get another a times b. And when I do the last, I get a b squared. Every perfect square that starts like this, two values being added together, will always produce that same looking result. Okay? So I know that I will have, and this is exactly what Anna got us to. She was like, wait a minute, I don't need to do that. I know what's going to be in this answer. It's going to be a perfect square in the beginning. It's going to be two of those ABs, right? So in our last one, we finally realized instead of a 3 and an X, I could just double those together and make it a 6, right? And then at the end, a B squared. That form will always be what my answer looks like when it starts with sides that look something like this A plus B over here. Okay? And so by definition, that is called a perfect square trinomial. And if I thought about foiling it, that would kind of be the process that I get. Right? So part of your homework, what's up? Yeah, but that's exactly what's over there, isn't it? This looks pretty with all the colors?
Yeah.
All right. So part of your homework tonight, and your homework is a total of 8 questions, so it's like killer, right? I know. Tell me about it. Okay. If it originally looks like this, a plus b squared, whatever that happens to be, it is guaranteed that your answer will look like that. Okay. So we're just going to look at, well, I have 3 on the next screen. If we've done any of those 3 already, then we'll just cross them off. If we haven't, we'll add those to what we have right now to start with. Okay. Kyler, am I good or do I need to hold a sec? Okay. This is what your book uses. They will give you this phrase, the square of a sum, but it's exactly what we have here. I use the phrase perfect square trinomial, and obviously PST is just an abbreviation, so you don't have to write perfect square trinomial. Lazy, you know what I'm saying? Thanks a lot, Jack. All right. So, oh, are you kidding me? All right, scrap this one. We're changing it. Let's make it a 7. See if you can answer any of those thinking along these lines without foiling them together. Obviously, you can if you have to, but can we do it without foiling them? Did we do 8 too? Gosh darn it.
3, 8, and 5.
All right. Maybe subconsciously I knew that. What do you think? Ha, you're not giving me any credit. That is right. What do you got?
I don't know.
Yes, yes, no.
Is it because
Both of these are not right.
it's just been
2 times 2.
Oh yeah, because you're multiplying it with it. Okay.
Even if you were adding, it's still 2 plus 2.
Yeah. Wait, I think it's wrong.
Yes, yes, this one's not.
What did I say?
Well, if you think about that first term, it'd be a 2x and a 2x. So if you multiply those together, that'd be 4x squared. And then this one here in the middle would be a 2x and another 2x. So it actually would be
Add that one
a
too.
4. Yeah. And the last one, 1 times 1 isn't 2.
Oh my gosh.
It's all right. That one's a little tricky. Yep. Yep. You just bowed out on that last one. Come on, Giannis. Good, good. This one is everything except for the middle is correct. The middle's not a 2.
Oh, never mind.
What'd you just say? Good, good. This one, the first part is right. Those 2 are not. They're close.
C, should I write it out? I don't know how to do it.
That definitely is a 2, and you have a 5.
Yeah. Is that not it?
Dude, that's a 2.
Yeah, I know.
Why do you have a 5?
Because once you add the variable,
Huh?
or is that not the same concept?
Oh, it is the same concept. I'm not sure where you're coming up with that, though. You're making me nervous.
2 times 2, right?
Yeah? It's
4.
4.
And then
4x squared.
This one, he's just doing the whole equation. He did.
Look, you got an x squared at the beginning of this
Mhm.
because you did x times x and got x squared.
Yeah.
Well, that's 2x times 2x, so that'd be 4x squared.
He flips with twos right now.
That is and that is, but this is not. Yeah, beginning and ends are good. The middle is not. Yeah, good work. What do you got? You're good? Good. First 2 parts are good. The last is not a 2. Good, good. This one here, we could put those 2 together. Yeah. Very good.
Is the
Change
4x
that?
squared
That is
right?
not right. The first part is not. Yes, that's good. That's good. The middle is not a 6. On the last one? That's right. 4x squared. The first part should be.
Okay, yeah.
Yeah, what?
I don't know.
Oh. What do you got? Everything except for that very end would not be a 2.
I'm so confused.
Yes. All right. So first of all, there's no confusion. The first two, you guys, I didn't see a single person got either of the first ones wrong.
There's no coefficient.
Okay. So this first one here, the x plus 7 squared, what does that result in?
X squared plus 14x plus 49.
All right. So x squared plus 14x plus 49. Now, what about the bottom one?
X squared plus 12x plus 36.
Listen to you guys. All right. I'm using these ideas to produce this one. It's all the same. How did we get x squared in the first part?
You put the x squared.
We put what did we multiply together? X times x. So over here, what am I multiplying together? 2x times 2x, which is 4x squared. Now, how did I get the 14 in the top one, or how did I get the 12 in the bottom one? What did I do there? So here, it was essentially, if I thought about this one, it would have been the outers were 6x and the inners were 6x. Here, it would have been 7x and 7x. That's how I got 14 or 12. So over here, what am I putting together?
The 1 and the 2.
What is it? Well, so we're multiplying, right? So okay. If I had another one of these, and you thought about the outers and the inners, what's going together? 2x times 1, which is 2x, but then you got to have 2 of them. So this is really a 4x in the middle.
Wait, but if you have,
Why are you yelling at me?
if you,
If what?
if you have your 2x, why do you need to multiply it by itself again?
Same thing here. I had to have 2 of these 7x's. Think about the middle.
That's just 7 times
It's a
2. It's not.
If I had
Because 7 times the 2, the 6 times the 2, and then the 1 times the 2 would be 2x.
if I had the x plus 7 and the x plus 7, the outers make 7x, the inners make 7x. That's how I get 14. Here, if these aren't, the same setup as the ones up top, I still have the outers I have to put together, and I still have the inners that I would have to put together. It's essentially these two items right here put together and doubled. Now, on the end, how did I get a 49 or a 36? Correct. It's that last term squared or doubled. So in this case, it's a 1. Well, what's 1 times 1? 1. But a lot of you guys had a what? Had a 2. Okay? Listen, if you struggle with this originally, and this is supposed to really be like a shortcut if you recognize it, if you don't, what should you do? Foil it till you get the hang of it. Okay. Now I told you we were looking at 3. Number 2 is exactly the same, except now it's no longer a sum, it's a difference. Okay. So if we come over here to the board, I'm not going to write a plus b squared. I'm going to write a minus b squared. What's going to change in here? You're on the right track. I'm not going to be dividing. Where a negative is going to take place. If I FOIL A minus B and A minus B, well, okay, so let's do this one step at a time. What happens first? What's my F when I do A minus B times A minus B? What is it?
Like
A squared, right? A times A, it's A squared. Now, if I do the outsides, it's A times negative B, so that is negative AB. Then I got to do the insides. That's also negative AB. And on the end, it's negative times negative, so it's positive B squared. Now, if I clean this one up, I get A squared, not plus 2AB. I get minus 2AB plus B squared. So it's exactly the same, except in the middle, right? I mean, if we look at it over here, in the middle, instead of having a plus 2AB, I get a minus 2AB. So you could look at any problem that we've currently done. And if I change the middle of any one of those, like the very first one we did in class was x plus 5 squared, correct? If we change that from saying x plus 5 to x minus 5 squared, you should already know what the answer is. It's going to be x squared minus 10x plus 25. It's exactly the same. The only difference is instead of having two identical middles that were positive, you have now two identical middles that are negative. If I said, oh, I'm sorry, that was really supposed to say x plus 5 squared, you say, okay, now that's a plus. That's the only difference between the two. Wow. All right. So we were going to do 3. There's the second one already. Okay. I kind of have a square as well that kind of follows that thought process. So again, you have that perfect square at the beginning. Your rectangles that are made up of one of each of those terms now are negative because of the minus in there, but you still, again, have the square at the end. Okay? So, I think we've done these, haven't we? No?
We did plus 6.
Okay. So then you should be able to give me an answer to that quickly. You should. I get.
The second one would.
She said, "Whoa, whoa, hold your horses."
M second.
Okay. All right. Okay. Got it.
Probably just really fresh in your brain. That's why you write them down.
I don't know what it is. So this is still considered a perfect square trinomial. It still has 3 parts. It still has perfect squares at the beginning and at the end. Okay. That's lovely. Yep. Absolutely. So that first one, Ben, what do you have for an answer to the first one? Okay. Now, if I heard you correctly, that's what I wrote, but you're missing one thing. X squared. Good. Remember, that term at the beginning has to be a perfect square, x times x in this case. The end has to be a perfect square. In this case, 36 is a perfect square. And the middle is 2 of those values there, the x and the negative 6 put together. Okay. Last one? Logan, what do you got? M to the second minus what? 6. How about m? But all right. Got you. Plus 9. Very good.
Is that all?
Well, I told you there were 3. Clearly, that's 2.
Oh.
Now, the third one, though, is simply a combination of the 2. Now, how could that be?
Oh,
What?
do you like make one positive and one negative?
Okay, good. So the third one is no longer what's called a perfect square. The last one is what is known, and this isn't obviously possible if one can't have a square that they're not the same, right? But one positive set and one negative set, that is called the difference of two squares. Now, I abbreviate that with dots, D-O-T-S, instead of difference of two squares. Okay. So if we add that over here to this list, the difference of two squares will be exactly what you guys just said. It has one positive set and one negative set. Now, if you kind of take these two ideas and bring them together, what happened when we had two identical positives? What happened in the middle? But that we added those two together, they doubled. If we had two negatives, what happened? Us, well, we added them together, did we not? But we just added two negatives together. If you have one of each, you have none, right? Look at this picture over here. We still have the a squared at the front, but now these rectangles that we're matching, if one of them is a positive version and one of them is a negative version, they're actually going to cancel each other out. And on the end, you have a positive b and a negative b. You get this minus b squared. So what we end up with is something that looks like this: a squared minus b squared. That's where the name comes from. Difference, meaning subtraction, of two squares. So you end up with something that falls in line with that. So over here, we could say, if we FOILed this, it'd be a squared minus ab plus ab minus b squared. And that turns into a squared minus b squared. Okay. So not really three ideas, like 1.5, right? I mean, one idea, we switched it to a negative. That wasn't really anything new. And the last one was kind of just, well, what if it looks like those two combined together? Okay. So we have three here that we're going to look at, and then we're done. Well, okay. So because you see the positive and the negative, that is this last idea, the difference of two squares. Mm-hmm. Yep. Now, again, any one of these you could FOIL to get an answer. Like, don't feel like if you're not catching on to it quite yet, that you can't FOIL your way to an answer. Good. There's the first one. So remember, if you were to FOIL this out, there would be four terms here originally.
Yeah.
In the middle, one of them would be a positive 4x. The other one would be a negative 4x, and they would knock each other out in the middle. That would be your final answer. But really, at this level right here, you need one more 4x in there. It just has to be a negative.
I got that.
Right, because that's what happens
Yeah.
in the middle. So we don't need it. And then on the end, it'd be 4 times negative 4.
It would be.
Well, sure. Think about foiling.
Yeah.
Which parts of the FOIL process go away in this problem?
All of it.
Not all of them. What?
What is this one? Oh.
The O and the I both go away. Mm-hmm. Because they can't, just like what you showed me, they cancel each other out. So you're left with the F and you're left with the L,
So then you
right?
just,
The first and the last.
so then you just multiply the 4x
Huh.
times 4.
Uh-huh. Look at those two 4x's right there. One's positive and one's negative. What's going to happen to them? What's positive 4 and negative 4? Yes. Yes. Yep. They cancel each other out. So that just would be gone in the middle. Yep. And yep. Uh-huh. So if you think about this here, that's definitely a part of what's going on, right? That's my x squared. These ones here are a negative 4x. That's a positive 4x. And on the end, a negative 16. But because I had opposites in there, that part's gone. And so my final answer is x squared minus 16. The difference, subtraction, of two squares. X squared is a perfect square. 16 is a perfect square. If you recognize that, you don't need to FOIL it. So as I look at this one here and say, wait a minute, those two factors are the same, one positive, one negative, my final answer should be d squared minus 49. Now, you want to put plus 7d and minus 7d in the middle and then cross them off? You can, but if you recognize it, you don't have to. Okay, you have a question to that?
Yeah. So in the formula we used, it was a squared minus b squared.
Uh-huh.
That's not squared.
Okay, so remember, this is a plus b and a minus b. So the d is in place of the a, so a times a, or d times d, that's how I got d squared. The b's are replaced by 7s right now, so 7 times 7 is 7 squared, or 7 squared is the same as 49. Okay, last one. Again, identical factors there. So we don't need the outers and inners. They'll cancel. You know what it is, Kay? There you go. 9y squared minus 4. Okay. All right. So just a couple. Nothing crazy to look at. Okay. 22 through 37, the first column. That is 6 questions. All right. Truly, if you got the hang of this, you really won't have any work at all. If not, it's okay. FOIL your work. Okay. Tomorrow, homework from section 8.2, 8.3, and 8.4. I will give you a review for your quiz. Your quiz will be on Monday. Questions with that right now? I will not.
Like come around and look
Yeah,
at
like
it.
I'm not going to keep it. Yeah. Okay.